Hello, PreCalc. We're going to review tonight, and we're working up our courage to take a take-home test. So I'm going to give you some expressions to practice, and it is November 1st. So we're watching this after Tuesday's class. One of the things on the test you'll have to do is graph the inverse trig functions, and those are y equals cotangent x, y equals secant x, and y equals cosecant x. Alright, so let's start there. That was a while ago, but you were really good at it, so let's bring that back to mind. We're going to do y equals 3 cotangent 2x. Alright, in order to graph this function, y equals 3, 2, let me move that over so I can have some face time. Alright, put it over here. Y equals, we're going to do 3 cotangent 2x. Alright, to do this you're going to need help, and that help is going to come from you looking for it. So you need your eyeballs, and your eyeballs are going to look in this fact, that cotangent x equals cosine over sine. Alright, when you know that to be true, your eyeballs look at the bottom, and that's your helper. So we're going to, instead of graphing this right away, we're going to graph this. We're going to take the sine function and put it in place of the cotangent, because we know wherever sine is a 0, then it would zero out the denominator of this function and create an impossibility, which we draw as asymptotes. So let's go ahead with that thought and draw in y equals 3 sine 2x. So this is the amplitude, so it goes up to 3 and down to minus 3. And then we're going to note that this 2, if you feed that into k equals 2 pi divided by the period, you will find out that this is our k. It goes in here. If you solve for p, you'll see that the period is pi. So I won't review that. That was the last test. So I know my whole sine function has to fit within pi radians. So it's going to go up to 3 and down to minus 3. All that in pi radians. That's my helper. So the whole reason I did the helping function was so that I could graph the asymptotes. So wherever they cross the x-axis is an asymptote, and they go on forever. And we will graph this piece up forever. And here's our asymptotes. And we're going to graph the function now, and recalling that cotangent are backward snakes. This 3, since there's no amplitude in a cotangent, it tells us that it stretches way out and doesn't have a wobble. You couldn't sit your glass of water there, so you're going to have to be thirsty while you graph this. Alright, so there's our first one, and hopefully you remember about that. Alright, let's try another one. I'll write it down, and you start it while I finish erasing. Here, I'll put the problem right there. And it's going to be y equals negative 2 cotangent x over 3. Alright, so you graph y equals negative 2 cotangent x over 3 while I erase the board. Go out and look for your help. Don't be too full of pride that you don't ask for help. I'll move this over while you're graphing away, graphing away. I see you in video land, graphing away. I'm just going to move it over. Y equals -2 cotangent x over 3. All right. Now, I was a little kind to you in the previous classes. I didn't give it to you x over 3. I gave it to you like this, 1/3 x. So first of all, you have to recognize that x over 3 is the same as 1/3 x, so that looks more familiar. All right, hopefully you're ahead of me. Did you graph the helper function? All right, the helper function is going to be, again, the sine curve. It's going to go down to 2 and up to 2. It's going to be flipped upside down because of the negative sign. And the function's period ends up being 6 pi. So the period is 6 pi. So I'll put in 1, 2, 3, 4, 5, 6 pi, and I'll mark 3 pi. Always give me some values on this graph. So some people like to keep me guessing on what, they just give me marks and they don't tell me any of them. At least give me 2. Alright, don't be stingy. So now I'm going to graph the helper function, which is -2 sine 1/3 x. So it's going to start here down low. I'm sorry, it's upside down. It's going to start and go low. So it's going to go bottom out here. Sorry. It's going to bottom out and come back up to here, peak, and then go back down. So that's it upside down because of the negative sign. It has an amplitude of 2 and -2, and it has been stretched out to 6 pi for its period. So now we're going to put in the asymptotes. And the asymptotes are, again, where this function is 0, and we can't have zeros in the denominator, and so on. So cotangent is the backward snakes, and if you drew them in with not very much wobble, like we did last time, you would be wrong, because this negative sign will flip those. So you can't get that from your helper. You have to realize that the negative cotangent means that everything that was down is going to be up. So it's going to go like this, which really looks like a tangent curve. So, all right. So because you were expecting the backward snakes, but the negative sign made them forward snakes. So how cool is that? I know, it's so snazzy. All right, let's try another one. And this one will be y equals secant of x over 2. So you can go ahead and graph that while I erase the board. Actually, I'll close this portion down and start at another portion. So, I'll be right back.